weeks ago, we released the synthetic oil investigation. We showed how a $2 powder had been sitting on industrial supplier shelves for 6 decades, while a $48 billion industry made sure most people never even heard its name. People watched it. People shared it. And then the comments started pouring in. Some of those comments really stopped everything cold, because the mechanics in this community did not just confirm what we found. They pushed the story somewhere else entirely. They pulled on a different thread. A thread tied to a system sitting inside every vehicle on the road right now. A system your dealer replaces on a schedule. A system that, according to engineers who actually work on it, is deliberately designed to corrode. We are talking about the coolant system. And once you understand what is really sitting inside that overflow reservoir and why it is there, you are never going to look at a dealership service estimate the same way again. One viewer, Michael C., wrote in after the synthetic oil video and said he is a fleet mechanic with 22 years working on commercial vehicles. He said, and this is the direct quote, his fleet runs coolant for 3 times the manufacturer's recommended interval by adding a single silicate-free corrosion inhibitor packet that costs less than $2 per vehicle. Think about that for a second. Hundreds of vehicles, 3 times the interval, $2. Then another viewer, Sandra, replied to Michael and said her husband spent $4,100 at a dealership last spring, replacing a water pump, a thermostat housing, and flushing a coolant system that had, according to the service ticket, failed due to inhibitor depletion. She did not know what inhibitor depletion meant. The dealer did not explain it. They just handed her the bill. And that is where this gets ugly. Because what she did not know, what they made sure she did not know, is that inhibitor depletion is not some random failure. It is not bad luck. It is not a surprise. It is a scheduled outcome. It is engineered in. Then viewer Paul D. sent something even more serious. Paul is a retired chemical engineer who spent 14 years formulating industrial coolant for heavy equipment. He said the chemistry behind consumer automotive coolant has not changed in any meaningful way since the 1970s. It is still ethylene glycol, still water, still corrosion inhibitors. But the inhibitor package, the part that actually protects the engine, is sized to last approximately 100,000 miles at standard operating temperatures. Not because that is the limit of the chemistry, but because that is the limit they designed into the product. The comments confirmed it. The engineers confirmed it. And then the specialists in the comments went even further. They revealed that the inhibitor depletion problem has a bypass, a real one, a $2 one. And the coolant industry, but really the entire service model around it, has spent 50 years making sure the average driver never sees it. So here is what is actually happening inside your cooling system. Ethylene glycol by itself does not protect the engine. It raises the boiling point of water. It lowers the freezing point. That is all. The real protection, the thing standing between your engine and a slow chemical death, comes from the corrosion inhibitor package. Silicates, phosphates, carboxylate compounds. These are sacrificial chemicals. They are designed to deplete. They coat metal surfaces. They neutralize acids. And in doing that work, they get consumed. When they are gone, the fluid left circulating through the engine becomes mildly acidic. And mildly acidic fluid sitting against aluminum cylinder heads and cast iron blocks starts eating them, quietly, gradually, predictably. That is not a defect. That is not an accident. That is not some rare event. That is chemistry every coolant engineer in the world understands. But really, what is astonishing is that no owner's manual explains it to you in plain language. Now here is the part they really do not want people to understand. The inhibitor package inside coolant is not some sealed, irreplaceable mystery. It is simply a collection of chemical compounds. And those compounds can be replenished individually for almost nothing. The heavy equipment industry has known this for 40 years. Diesel fleet operators have known it for 30. And the product used to replenish those inhibitors, a supplemental coolant additive, or SCA, has been available from industrial suppliers and commercial truck stops for decades. A single-dose packet, $2, added at each oil change interval. It recharges the inhibitor chemistry before depletion sets in. It keeps the fluid chemistry neutral. It extends the functional life of the coolant and the components it touches by a margin no manufacturer service schedule would ever advertise. Because if they told you the truth, a lot of people would stop paying for coolant flushes. And that is where the money enters the story. The coolant flush market in the United States alone is estimated at more than $2 billion annually. $2 billion. For a service that, if inhibitor levels were maintained, most vehicles would not need through the practical service life of the car. Let that sit for a moment. Because after the chemistry comes the strategy. And once you see that part clearly, the whole structure starts to make sense in a way that is hard to unsee. Now we get to the part that changes this from a chemistry story into a market story. Because the real question is simple. If supplemental coolant additives have existed for decades, if fleets have used them for years, if the chemistry is well understood, then why have most drivers never seen them on the shelf at a local auto parts store? That is not an accident. And really, that is where the system reveals itself. The consumer automotive aftermarket and the industrial coolant market operate like two completely different worlds. Fleet operators, agricultural equipment, mining vehicles, marine diesel engines, these sectors buy coolant chemistry by the drum. They monitor inhibitor depletion with test strips. They top off inhibitor packages on a schedule. They treat coolant maintenance as an ongoing process, not as a one-time replacement event. In those industries, chemistry is managed continuously because downtime costs real money and preventable failures are unacceptable. But the consumer market is built differently. You buy a car, the dealer tells you the coolant is good for 100,000 miles. Then, right around 100,000 miles, the coolant begins to fail. Corrosion starts appearing in the aluminum parts of the system. The water pump begins developing early cavitation damage. The thermostat housing, which on most modern consumer vehicles is now plastic, starts degrading at the sealing surfaces, and then the dealer steps in with the bill, not to prevent the problem. To profit from the timing of it, a $4,000 repair here, a $2,200 repair there, maybe $4,500 if the damage spreads. But the underlying chemistry, the root of the failure, stays unmanaged exactly the way it was before, and then it gets worse. In the 1990s, the industry moved away from conventional silicate-based coolant, the green coolant many people grew up with, toward what it marketed as extended life formulations, OAT, HOAT, G12, G13. Consumers were told this was progress, longer life, better compatibility with modern aluminum engines, better technology. But what they did not tell people is the critical part. Organic acid inhibitors are slower acting. They provide less immediate surface protection than silicates. They last longer in the bottle. They last longer on the shelf. But when they fail faster. And the timing of that failure really is where the business model becomes impossible to ignore. They fail at the exact point in the vehicle life cycle when the manufacturer warranty has expired and the dealership service department becomes most profitable. That is not just unfortunate timing. That is the schedule. The inhibitor chemistry was not chosen simply because it was best for your engine. It was chosen because it fit the service interval. And the service interval was engineered to expire at the mileage where the most money changes hands. Now put real numbers on it. A supplemental coolant additive packet, that small $2 industrial product that recharges inhibitor chemistry, added at every oil change interval, roughly every 5,000 to 7,000 miles, costs between $20 and $30 per year. Over a 10-year ownership period, that is about $200 to $300 total. Compare that to what happens when coolant chemistry is left alone. The average driver who does not maintain inhibitor chemistry will face at least one coolant system repair event, somewhere between 80,000 and 120,000 miles. The industry average cost lands between $2,200 and $4,500. And fleet operators who run SCA maintenance report that water pump life extends from an average of 90,000 miles to more than 200,000 miles. Not on some exotic industrial machine. Not on a specialized one-off system. On the same basic water pump architecture sitting in consumer vehicles right now, that difference is not small. That difference is the whole game. But there is a deeper historical layer here, and this part matters because it proves the consumer did not always live inside this closed loop. Back in the 1960s and early 1970s, coolant maintenance was more hands-on. Drivers could buy coolant conditioner, essentially an early version of SCA, at gas stations. Mechanics recommended it. Owners used it. And engines from that era, when properly maintained, routinely reached 200,000 miles on their original cooling components. Then everything changed. The industry moved into the era of sealed systems, pressurized overflow reservoirs, maintenance-free coolant, lifetime fluid language, cleaner marketing, simpler messaging. But really, that simplicity came with a cost the consumer was never shown. Coolant conditioner disappeared from the consumer shelf. Not because the chemistry stopped working, not because the need disappeared, but because the service model no longer needed informed owners. It needed passive owners. Owners who waited until the schedule expired, owners who came back when the corrosion had already started, owners who paid after the chemistry had done exactly what it was designed to do. Fleet operators kept using inhibitor maintenance. Commercial diesel mechanics kept using it, industrial suppliers kept selling it, and the consumer market was quietly handed a cooling system designed to degrade on a profitable schedule. That is the architecture. That is the pattern. And once you see it, the final piece becomes unavoidable. Because if the bypass is real and the chemistry is real, then the next question is obvious. What exactly should a driver use? How does compatibility work? And what can be done right now without making a costly mistake? So this is where everything Paul, Michael, and the engineers in the comments were pointing toward finally comes together. The bypass is real. It is available right now. And it works on the same chemical principle that has kept commercial fleets running for 40 years without destroying cooling components on schedule. What you are looking for is a supplemental coolant additive that is compatible with the coolant already in your vehicle. That word, compatible, matters more than most people realize. Because this is not a pour anything in and hope for the best situation. If you mix the wrong additive with the wrong coolant chemistry, you can create a different problem entirely. Silicate-based additives mixed into OAT coolant can drop out of solution and clog the heater core. And once that happens, you are not preventing a repair bill. You are creating one. So the first step is simple, but it has to be done right. You need to know what coolant your vehicle is already running. Check the owner's manual. Check the reservoir cap. In many vehicles, the coolant type is labeled directly. Green usually means conventional coolant and silicate-compatible SCA. Orange, yellow, or pink usually points to extended life formulations. In that case, you need an OAT-compatible organic acid additive. Purple or blue, often tied to European specifications, usually calls for HOAT-compatible products. Industrial suppliers carry all three categories. Commercial truck stops often carry them too. But the consumer automotive shelf, almost unbelievably, almost always does not. And that absence tells its own story. As Michael C. explained, a single packet added at each oil change interval, with the engine cold directly into the overflow reservoir, recharges the inhibitor chemistry before depletion begins to do damage. The metal surfaces remain protected. The pH stays neutral. And the corrosion cascade that destroys water pumps, thermostat housings, and eventually head gaskets never gets the chance to start on the schedule the service department is counting on. That is the heart of it. $2 per oil change, roughly $20 to $30 per year, against a minimum repair event of $2,200, and in many cases far more, arriving right at the edge of the warranty window where the system becomes most profitable for everyone except the driver. Across a 10-year ownership period, a driver who maintains coolant inhibitor chemistry is conservatively saving between $2,000 and $4,000 in avoided repairs. Repairs on parts that really should never have failed when they did in the first place. And once you frame it that way, the whole picture changes. This is no longer a story about a water pump or a thermostat housing failing early. It becomes a story about managed chemical depletion being turned into a repeat revenue model. It becomes a story about a known industrial solution being kept in one market and withheld from another. It becomes a story about consumers being handed a maintenance-free promise that was never truly free. That is why this matters. So now we want to hear from people directly. If you have had a water pump replaced, a thermostat housing fail, or any coolant system repair, share the vehicle, the mileage, and what you were charged. Your experience is not just a story anymore. It is data. It is evidence. And piece by piece, it reveals the pattern more clearly. Because this investigation does not stop here. The next one goes deeper under the hood, straight into the engine itself. Engineers have been writing in about carbon restriction and intake valve fouling, and the numbers behind how much power engines silently lose and how dealerships profit from that loss make this coolant story look like the beginning, not the conclusion. If this breakdown helped you see the system more clearly, leave your experience in the comments, stay with the channel, and follow for what comes next.